Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 9.4, solve polynomial expressions that are already in factored form. So we'll learn what factored form means later. Okay, so warm up. If two numbers multiply to 0, then what do we know about at least one of the numbers? How do we know this? So this is saying two things multiply to make 0. Okay, so what do we know about at least one of these numbers? Well, at least one must be 0. And that's because of our property of 0. So how do we know this? The property of 0, we learned this way back in chapter 1, says 0 times any number will always make 0. That's the only way we can get 0 there. So either the first number should be 0, and the other number can be anything we want, or the first number can be anything we want and the other number should be 0, or they could both be 0. So that's the only way we're going to get 0. At least one number is going to be 0 there. So if we look at number 2 here, this says if x times x plus 4 equals 0, then what do we know about the expressions x and x plus 4? And remember, an expression just takes the place of an unknown number. So once we pick the number, then we know the value of that expression. Okay, so we have this expression x times another expression x plus 4, and we know the answer is 0. Well, that means either x should be 0 or x plus 4 should be 0. Okay, those expressions, one of those expressions has to be 0. Okay, so one of the expressions should be 0. How could you use this knowledge to from exercise 2 to find out possible values for x? Well, it's easy. You say, okay, well, since one of these expressions has to be 0, then we could solve for x. We could say either the first expression is 0, which is just x, or the second expression should be 0. This one solved, so we know if x was 0, we'd have 0 plus times 0 plus 4, so 0 times 4 makes 0, so that would be at one possibility for x. And over here, if we solve for x, we get negative 4. That in the original problem would say negative 4 times negative 4 plus 4. Negative 4 plus 4 is 0, so that would say negative 4 times 0, and that would also be 0. Okay, so these are the two values that work. Okay, solve each for x. So we're just practicing what's up above. So we have two expressions that multiply to be 0. So that means one of those expressions, or both, should be 0. Okay, so over here, if we solve, we get 0. And on this side, we get 5. So here are my two answers of what they could be for x to make this equation be true. Okay, so once again, I'll plug them back in just to show. So we're going to say 2 times 0, 0 minus 5 equals question mark 0. So this would be 0 times negative 5 equals question mark 0, and that definitely works. And the other way, we have 2 times 5, which is 10, and then 5 minus 5 equals 0 question mark. So that's 10 times 0 equals 0, or 0 equals 0, which also works. So both of these work, okay, because they make one of those two expressions that are being multiplied be 0. Okay. All right, on part B, we have two expressions multiplied together to make 0. So since two things multiply to make 0, one of them must be 0. So we solve each one separately. So either x minus 2 could be 0 or x plus 3 could be 0. So if we solve this one, we get 2. And over here, we get negative 3. So there are two answers that make this work. If you plug 2 back into the original equation, we get 0 times 5, which makes 0. And if you plug negative 3 back into the original equation, we get negative 5 times 0, which also makes 0. So both of them work. Part C is no different, just gives us two-step equations to solve. So 3x plus 5 could be 0, or 2x minus 4 could be 0. And then we solve them separately. So x could be negative 5/3, that's one answer, or x could be 2, that's our other answer. Okay. And then in our last one, we have a monomial times a binomial equals 0. So the monomial expression could be 0, or the binomial expression could be 0. I solve them separately. So x could be 0, 3x could be negative 6, so x could be negative 2. And these are my two answers. Okay, these two values of x will make one of those two expressions be 0. All right, this concludes our first page. Let's flip it over and make it a bit harder. Okay, on the second page, we start off with definition from grade school. It says the greatest common factor. So the greatest common factor of two or more numbers is the biggest number that will divide evenly into the numbers, or all the numbers. For instance, the GCF of 20 and 25 is 5. So here's how we would do this in grade school. You thought of all the things that divided into 20, or all the things that multiplied to make 20 is even easier to do. So 1 and 20, 2 and 10, 4 and 5. Okay? And then we did the same thing for 25. So 1, 5, and 25. And then we look through our list and we try to find the thing that is in both, the biggest number that's in both. So in this case, it was 5. And that's why the answer is 5. 5 is the biggest number that will divide evenly into both 20 and 25. Okay? So what's the biggest number that will divide both evenly into 5 and 20? Well, the factors of 5 are 1 and 5, and the factors of 20 are 1, 2, 4, 5, 10, and 20. So we can see that 5 is the biggest thing that divides evenly. Okay? We don't need to show this work for me. As a matter of fact, our graphing calculator will do it for numbers, so we can find the greatest common factor with it, and I'll show you how that works in class next time. All right, so for 16, that's 1, 2, 4, 8, and 16. And for 20 is 1, 2, 4, 5, 10, and 20. And we can see that 4 is the biggest thing that divides evenly. All right, for 15 and 25, same kind of thing we would do. And you should find 5 to be the biggest thing that will divide evenly. And for 50 and 75, you can do the same kind of thing, or you can just think of what's the biggest number that divides evenly into both, and that's 25. 50 is 2 quarters, and 75 is 3 quarters, so it divides evenly into both of those. Okay. Number 3, let's take this one step further and add some x's in here. So things that could divide evenly into 5x. So this is a little bit different. So it's going to be 1 and 5x, okay, or 5 by itself, or x by itself. Okay, those are things that would work. 20x squared, okay? So 20x squared, well, we have to list all the things that could do 20. That's a lot. And then we also have to pair an x and an x squared with them, okay? Because we could divide 2x squared into this. So this is way more than I really wanted to list. Okay, so I think about the numbers first. The greatest common factor of 5 and 20 is 5. And if I think about the x's, what's the most number of x's that could divide evenly into both? And that's only 1, okay? If I tried to divide them both by x squared, then this one would make a fraction, so it wouldn't work, okay? All right, so over here, what's the biggest number that will divide into both 2 and 4? Well, that's 2. What's the most number of x's that will divide evenly? And that's only 1. If I try to divide the x squared, it doesn't work to both of them. And the same with the y. The most number of y's that will divide evenly is only 1. Okay. In part C, the 9 and 12, the greatest common factor is 3. The biggest number of p's that can divide evenly into both is p squared. Okay, that won't make any fractions. And the most number of q's that can divide evenly into both is 1 single q. Okay, for 2x and 4, the biggest number that will divide into 2 and 4 is 2. And I cannot divide any x's into both of them evenly without getting a fraction, because if I try to divide the second one, 4 by x, I get 4 over x, which is a fraction. Okay, I won't divide evenly. So for E, 8 and 16, 8 is the largest number that will divide evenly into both, and x is the largest amount of x's that I can divide evenly into both. And for our last one, 5 is the biggest number that will divide into both 10 and 15, and y is the biggest amount of y's that will divide evenly into both. Okay. Let's flip it over and see if we can build on this a little bit more. On our last page, we start with the definition for factoring. To factor a polynomial, it means to write the polynomial as a product of other polynomials. Think of it as the reverse of what we used to be doing when we simplify. So like an undistributive property. Okay, so before we do that, let's talk about factoring without polynomials. So just factoring 20. So factor means to change 20 into two things that could multiply to 20. So there's a couple ways to factor this. We could factor it into 4 times 5. We could factor it into 10 times 2. We could factor it into 1 times 20. So we're just thinking of things that could multiply to make 20. Okay? Same thing what we're doing here. So if we wanted to factor 3x squared plus 6x, the first thing we need to do is think of the greatest common monomial, or the greatest common factor for the two terms. So we just did that on the last page. So 3x squared and 6x. Well, what's the biggest number that divides into both 3 and 6 evenly? That's 3. And what's the biggest amount of x's that can divide into both evenly? And that's 1. So we factor this into 3x, and then we figure out what did we leave behind. So 3x times what would make 3x squared? Well, we left an x behind in the first term's position. And then 3x times what would make 6x? So that would be 2. So we have the 2 behind in the second position. So I said think of this as like undistributed property, because that's what we did. We took something like this and we undistributed it to 3x to get it on the outside. Okay, so remember these expressions are equivalent, and notice that the 3x is the greatest common factor of 3x squared and 6x. So we do need to factor out the greatest common factor, not just a factor, okay? All right, so number 5 says, factor the greatest common factor in this polynomial expression. So what's the biggest number that divides evenly into both terms? Well, that's a 5. The biggest amount of x's that divides evenly into most terms is none, because the second term doesn't have an x, and the same with the y's. The first term doesn't have a y. So now we think of what got left behind. So 5 times what would make 5x? Well, that first place has to be an x. And then 5 times what would make 5y? Well, that would have to be plus y. So 5 times x is 5x, 5 times y is 5y. Remember, you can always check yourself by redistributing the GCF back in to see if it worked. All right. So for part B, the GCF of 8v cubed and negative 12v squared. Well, the GCF of 8 and 12 is 4. And then GCF of v cubed and v squared is v squared. And then let's see what I got left behind. Well, 4v squared times what would make 8v cubed? Well, that's going to be 2. 4 times 2 for 8. And then I need a v squared, but it needs to turn into v cubed, so I need 1 extra v here. And then for our second term, 4v squared times what would make negative 12v squared? Well, 4 times what would make negative 12? That's going to be negative 3. And then I already have a v squared, so I don't need to put any more v's left on the inside. Okay. Part C, 14x to the 5th minus 7x cubed. So what number divides evenly into both is 7. The most number of x's that could be divided evenly is x cubed. And then we figure out what got left behind. So 7 times what makes 14? That's going to give me a 2 here. And then x cubed times what to make x to the 5th? That's got to be an x squared, so I can add the exponents to get 5. And then 7 times what would make negative 7? That's going to be minus 1. And then I already have the x cubed to go with it. Okay. And our last one, part D. B is the only thing that can divide evenly into both. And then that leaves behind 1b, because b times b for b squared, and minus 6, because b times minus 6 will make negative 6b. All right, so you might say, well, why are we even doing this? Well, here's why. Okay, we can now solve equations that we could not solve before. So in number 6, parts A, B, C, and D, we have equations that you would not have been able to solve with the steps that we've learned so far. So what we can do here is look at this stuff and say, oh, what's the GCF of these two? So this is going to be 3x, and what will get left behind is x minus 2. So we factored on the left side of the equation. Okay, whenever you have an x squared, you're always going to have to do some factoring for the most part. Okay, and then we look at it and go, oh, we learned this trick, how to solve this on the first and second page. So this is two things multiply to make 0. So 3x could be 0, or x minus 2 could be 0. And that means x is 0, or x is 2. So here's an equation that we could not have solved before today if I'd given it to you, but now you can do. Okay. Second one, part B, same thing. The greatest common factor is 6c, and that left behind 3c plus 1. And now I have two expressions multiplied to make 0. So that means one of the expressions must be 0. So either the first one must be 0 or the second one must be 0. And then we solve these two separately. So c is 0 or 3c is negative 1. So c is negative 1/3. Okay. And in our last one, we're going to do the same kind of thing. Last two here, but notice on A and B, we already had 0 on one side of our equation. In order to make this work, we always have to do this. We've got to solve this equation for 0 first. So we're going to subtract 16x to both sides and write this equation equal to 0 so that I can factor and break my factors apart. So my GCF here is 8x. That leaves behind x minus 2. Then we solve each one of these separately. Either 8x needs to be 0 or x minus 2 needs to be 0 because these two expressions multiply to make 0. And two things that multiply to 0 means one of them must be 0. So we solve them separately. We get 0 or we get 2. And in our last one, we move the 4x over to the left side with the x squared to set it equal to 0 first, so we can do our trick of factoring it. And then we know if two expressions multiply to be 0, then one of them must be 0. And that allows us to solve this equation. So here are our two answers. All right, this concludes the notes today, but I really suggest if you looked at these problems and you don't know what I'm doing, go back and re-watch again. Okay, see all the little parts that we did leading up to how do we solve the stuff in number 6, because this will be on our test coming up very soon. See you in class next time.